Now, one of the things that we will measure as we are studying a microbe, as we are studying a bacteria, is we will determine how long it takes for that culture to grow. How long does it take to go from one cell to two, two to four, four to eight, and so on? We call that the generation time. How long does it take for the population to double? One to two, it's doubled. Two to four, it's doubled again. As we're going and we're looking at this, we will measure. We'll start with a low number of bacteria and just allow it to grow in a large culture, sampling every so often, counting how many cells are there so that we can determine just how long this takes. Average 30 to 60 minutes. It can be shorter for some, longer for others. On average, Staphylococcus aureus, as quickly as 20 minutes, but on average closer to 30. So every 30 minutes, staph, 1 to 2, 2 to 4, 4 to 8, and so on. Mycobacterium is known to be a really slow grower. Mycobacterium leprae, which causes leprosy, or now it's commonly known as Hansen's disease. Anywhere from 10 to 30 days, depending upon culture conditions. Think about that. 10 days to go from 1 to 2. Another 10 days, 2 to 4. So it's a slow grower. So when you look at the population in a culture, we discuss it as being an exponential growth. It's not slow, because when you look at to the far left, you see that it's 1 to 2, 2 to 4, 4 to 8. It's multiples of 2, 2, 2, 2. But as you get going and it gets growing and the population increases well beyond millions to billions to trillions, sitting there and saying 2 to the exponent of 300 really doesn't tell you much. So we will actually start labeling it logarithmically, either as log base 2 or, from what I was taught when I was taking microbiology courses, log base 10. So that way you can use scientific notation. 1 times 10 to the n.